In this second tutorial, we'll show you how to actually use the node editor in scNodes to do super resolution fluorescence data processing. First thing to do after opening up the editor is to right click anywhere and then go to Data EO and select a import dataset node to add. That adds a new node to the setup. Then find the file that you want to process. In this case, that will be the tutorial dataset. Select it, press enter, and it pops up in the image viewer. And when you browse through it by using the slider at the bottom here, or the arrow buttons left and right, or by scrolling, you can see that there's quite a lot of drift in this particular dataset. So the first thing that we would want to do is correct for that drift. So we will use a drift correction node. So you right click in the editor and then go to image processing registration. There are a bunch of methods that you can use. In this case we'll use PyGPUReg, which is our GPU accelerated drift registration module, which is fast enough. Let's see. Now you have to set a template frame as well, so in this case it's selecting frame 0 as the template, which is a reflection image, whereas the other 1,000 images in this dataset are fluorescence images of RCGFP2 labeled Vimentin in UTOS cells imaged in a cryostage. So we'll use any of these fluorescence images as the template, let's say 400. And now when we slide through the stack, you'll see that the drift is largely gone. So, up next would be background subtraction. Let's use a difference of Gaussian filter. And again, if you browse through the stack, you can see the result of the on-the-fly processing. So we're starting to make out a lot of particles and events that appear over time, which we would want to detect now, for which we'll use a particle detection node. So again, add that by right-clicking and then selecting whichever node you want. And if you see me moving around the camera here, that's by pressing the scroll wheel or the middle mouse button and then dragging everything around. Again, connect this node to the pipeline and you can see the results. And then finally, and this is going to be a fairly linear setup, we'll use a BSF fitting node and connect that to the coordinate output of the particle detection and to any dataset. Now it could be the filtered version or the original one, but in this case we would want to use the drift corrected version of the raw data. And each of these red crosshairs that you can see here is the final result of a localization. So if we are happy with these results, which we are, then let's tell this final node to process everything. Or let's actually use a random subset first, just to check if the output is what we want. So select random subset, let's go for 100 frames, and I've not touched the settings in any of these nodes, but what you could do if you want to play around with it a little bit more is right click the BSF fitting node and select focus node. And now all the output that you'll see in the image viewer will always be the output of the BSF fitting node, or whichever node you've focused. And you can change the settings of, let's say, the particle detection node by lowering the sigma. Control click to enter a custom value. Let's set it to 1. And as you can see, a bunch of new particles appear. Or disappear. So let's go for a sigma of 1. Random subset, 100 frames. Defocus it for now and press go. When that's done, you can add a render reconstruction node to actually visualize the final reconstruction. Connect it to the BSF fitting node. Let's go with the default pixel size of 10 nanometers and press render. And then there's our reconstruction. Now this is only based on 100 frames, 100 random frames, but it looks quite alright. So let's just process the entire dataset. wait. Now this has been pretty much the simplest possible piece of fitting setup that you can build, but it works. So let's see what the final reconstruction looks like then. Press render again to update it, and there you go. Now here, if the contrast settings are a bit off, you can use Ctrl-Shift-C, or just right mouse click and then brightness contrast to open up this window. And let's set it to always auto contrast. And that's the reconstruction. Now if we're satisfied with these results, and we could do a bit more, we could add, let's say, a drift correction node that corrects for drift based on the particle localizations. We could use temporal filtering steps to subtract background in case you do photo activation type of microscopy, and various other things. But let's say that this is it, and we would want to reuse it for the next experiment. Then you can go to File, Save Setup. I'll stick it on the desktop for now, and call it scNodes tutorial BSF fitting setup. Then the next time you start up the software, the node layout will be clear, but you can simply load it by going to File, Load Setup, and then opening that previous layout that you've made.